So this video is on rational and irrational numbers. You should be kind of familiar with this, but just as a review, a rational number, it's called rational because it's literally a ratio of two integers, two numbers. Integer could be something like 2 and 3. That's a rational number. Or negative 2 and 3. Or 5 over 1, which is just 5. Or just any two numbers that make a ratio, that's a rational number. This includes all the integers, like whole numbers and negatives. This includes any fraction, because that's literally a ratio. And it ends up being any decimals that end. So if it chops off, we could make a fraction out of it. Or if it repeats, we could make a fraction out of it. Basically, the only thing that's not included in rational numbers are irrational numbers, which just means not a ratio. And the only thing this includes are just decimals that go on forever without repeating. They don't end. For example, like pi. You can't make it by dividing two integers. Just as a bit of a side note, remember our first Tuesday tale was that, remember Pythagoras and his cult basically thought that irrational numbers did not exist. They were wrong. But then a guy named Hippasus proved that the square root of 2 is actually irrational, that it's a decimal that goes forever without repeating. And the myth goes that Pythagoras and his brotherhood got so angry that they tied him to a rock and threw him off a boat. So you gotta look out for these irrational numbers. Okay, so this is gonna be the practice we're gonna do in class today. If you're watching this video on your own, pause the video and try each of these and see, are these rational or do they come out irrational? For example, pi. Pi we often approximate as 3.14, but it goes forever. We know like billions of digits of pi, by the way. Just wait for Pi Day in March. So pi cannot be represented as a ratio. It's a decimal that goes on and on forever without repeating, without ending. So pi is irrational. If I were to do this, a lot of square roots come out irrational. You can see that in your calculator. Your calculator rounds them, but you can tell that they just go forever. So this looks like it's going to come out irrational, but if you actually work it out, square root of 49 is 7. 7 plus 2 is 9. And square root of 9 is 3. So that actually comes out to be rational, because it's a whole number. This one, same thing. Square root of 12 is irrational, and square root of 3 is irrational. But when I combine them, 12 times 3 is 36, and the square root of 36 is just plain old 6, a rational number. So that's kind of interesting. This right here is e. E is not actually a variable. E is a number, like pi, that you might see here in the future. If you look on your calculator, whatever calculator you're using, you'll probably see an e. E is about 1.7, and then it goes on forever, and you'll use it later. But e is irrational. It's a decimal that goes on forever without repeating. And if we square it, it's still going to be irrational. You can try that in your calculator and you'll see. So this one was irrational, this one was rational, rational, irrational. This one, when we put the little line above it, remember that means it repeats forever. So since this repeats forever, that makes it rational. If a decimal ever repeats, it is rational. Even if it goes forever, it's still rational if it repeats. This big old mess, you could type it into your calculator, or we could simplify it by hand. That's going to be 9 and 3, and that's just a 3. 2 times 3 is 6, so 6 root of 3 minus 1 root of 3 minus whatever this is. I'll break that into 25 and 3. Square root of 25 is 5. So this whole thing becomes minus 5 root of 3. Okay, it seems like this is going to be irrational, but watch. I have 6 root of 3 minus 1, so now I'm at 5 root of 3, and then minus 5 root of 3. So if I have 5 of something and then I take 5 away, that leaves me with 0 root of 3. And 0 times anything is just 0. So that is a rational number. 0 is a whole number, which is included in the rationals. So that one came out rational too. Square root of 8 we could try to break down into like square root of 4 and square root of 2, which becomes 2 root of 2. But that's still going to be an irrational number because 2 times the irrational number is still going to be irrational. If you don't believe me, just put it in your calculator and you'll see that one is still irrational. Nothing fancy happened there. And if I do like 1 plus square root of 5 over 2, I get this big long decimal with dot dot dot, meaning it just keeps going. It doesn't look like it repeats or ends at all, and so this one is also irrational. So there's nothing really to memorize here. You just have to try a problem like this and see what happens.